You can check the presentations, download the slides, and the full discussion, as well as the questions that are posted on the website. So today we're going to have a more open discussion, mainly about benefits, challenges, and impact, but also some aspects that were left out on the other previous sessions. So we're going to start with some of the benefits of distributed generation. Then I'm going to share with you some cost structure analysis that I've seen posted or available on the web, and some that I've conducted myself, and some of my consultancy that I think brings some interesting points cost-wise. Also, we're going to have a perspective of what these new trends in distributed generation and solar PV is doing to the job perspective, and then discussing some of the future trends, current challenges, and unsolved questions. So I hope we have some time for interesting questions at the end of the discussion. So starting with the benefits of distributed generation that I believe most of you probably already know some of these and are aware of these, but let's just do a recap of some things that we've been discussing throughout the webinar. So first of all, of course, by installing a distributed generation system, we see that the end user has a potential for savings on their electricity bill. Also, I like to point out that there's usually savings to the electricity system as a whole. This may vary depending on the country, but if you take it, this is true actually for most renewable generation. But if you think for a moment about distributed generation on the demand side, so that's when it's installed by the end user, it's normally mostly a private investment. So it's not the grid operators that are doing the investment, but the user. But what you're displacing with these new generation sources is normally, or is usually, marginal generation. So and in many countries, this marginal generation, because of the way the electricity matrix and the generation market is set, is mostly fossil fuel driven, sometimes liquid fuels, or sometimes natural gas. But in the case, especially in the case of liquid fuels, diesel or fuel oil, it's the most expensive. So by displacing these sources, we're having some savings for the system as a whole. Also, in many cases, and this is something that's very relevant in Argentina, but as well, I imagine it's relevant as well in other countries, when you have subsidies to your electricity bill, the generation by the user will avoid the subsidizing that electricity, the portion that the user is generating. So this is also important, and also this could be a good argument for the provision of incentives from the public budget to incentivize this activity, because you are transforming a cost that is the subsidies in electricity to an investment that will make you need less and less subsidies going forward. From the energy perspective, as we discussed, and it's obvious, you have loss reduction in distribution and transmission networks, because the electricity doesn't travel as far. Even if this is done in low voltage grids, the energy that's injected, the energy that's self-consumed by the user, of course, has almost negligible losses, but the energy that's injected to the grid is also consumed by neighboring users, so the losses are minimal. Energy efficiency through self-consumption is a very important point, not only because of the loss reduction that I just mentioned, but also because when a user considers installing a distributed generation system or having their own generation for electricity on site, necessarily and almost every single time they start by doing an energy efficiency assessment and analyzing all the consumption that they have internally. Of course, there's restrictions that we discussed to system size and of course of the cost also as well of the investment. So you want to make sure that you can adapt and not only have generation but also reduce your consumption. I think this is very important, not only from a technical or energy perspective, but also from a cultural point, because what you see, and especially with users that are not normally in contact with the energy system or energy variables, is that they start to think a lot more about what their energy consumption is and how they're using their electricity once they realize that they have a limited resource at home and they try to make the most of it. So this is a very important point, and it should be taken into consideration and combined. If in the case you have multiple policies, make sure that you have a synergy between them and the incentives are set accordingly. Again, demand reduction is something important, not only because of loss reduction, but also because it reduces stress on the grids. Also, something that's important is that the growth on electricity demand will be slowed by the increase of distributed generation, because of course when you plan for the expansion plans for the grid, take into consideration the increase, the yearly or periodical increase that you will have in demand as the users start increasing the demand in electricity. And we're going to discuss some of the things that are happening on the demand side at the end of the presentation. But what I mean to say with this or point out is that by slowing the growth of this demand, you might maybe you will still need the grid improvements for expanding the capacity, but you will need them later, and this will bring some financial benefits by deferring these investments. And then, of course, for environment and society, we all know that this is mainly driven or originally driven by the effort to mitigate climate change and reduce CO2 emissions in the case of the electrical sector, but also we're going to see what the evolution has been and what the potential of distributed generation is for qualified job creation, which is something really important for all our countries. So now if we dive into the DG cost structure, especially or particularly for solar PV, there's a very interesting research that was done in Mexico by GIC. I have the link here. I'm putting all the links on this important research or information that I'm sharing, so you can check all the details. But what I'm trying to, even if you're not in the Mexican market, this should be interesting. So this is information. This was released in March 2020. So this is very up-to-date information. And if we look at what we see here price-wise, and if you look at the range of system sizes, you will see that these are, especially if you have been watching or following the development of the capex cost or the cost of investment for solar PV, these are remarkably low numbers. And if you look at the system sizes with very small or medium-sized systems, you see that we are below the $1.5 per watt, and of course without VAT, but still these are very, very low prices. Just as a side note, when the Renewable program was launched in Argentina in 2016, which is a utility scale tender program, the maximum capex that was estimated for utility scale solar plants was around $1 per watt peak. And now, just 4 years later, we can see that these numbers are very similar to what utility scale numbers were a couple years back. So this this comes along with what we showed at the global perspective, but also at the local perspective, prices are dropping really fast, which is great for development of these applications. Now going into some study that I recently conducted for Argentina, I'm going to point out what the components of the cost structure are for solar PV. So of course, we have solar panels, the solar inverter, mounting structures, electrical materials, as you can imagine, all wiring, cabinets, the junction boxes, breakers, some protections or atmospheric dischargers, and so on. The installation service, which is very local in nature in this case, because these are small systems. So in comparison to utility scale, you won't see a lot of people traveling around for installing 10 kilowatt systems. Mostly it's a local job creation. And then we're considering gross margin, which includes basically everything that's not above indirect cost to the installation company, administrative jobs, commercial jobs, management, of course, also income tax, and the utility to the company. And lastly, the value-added tax that might vary on each country. And actually, in Argentina, it's different in the different components. But to have a general perspective to this, we analyzed 3 different scales of systems. So 3 kilowatts, 10 kilowatts, and 50 kilowatts, trying to look at, in general, what residential, commercial, and industrial sized system would be. And these are very current prices. This was done in the last couple months. And in the case of residential, here the value-added tax is included in the price. It's almost a bit below $2 per watt. In the case of commercial and industrial, see that the prices are considerably lower. And something that's interesting to point out is that the VAT does not impact commercial and industrial users the same way it does residential or end consumers, because commercial and industrial users can deduct the VAT from their taxes. So basically, they're not impacted by this tax when they purchase the system. And then again, we see here we have in 50 kilowatt systems, which is not that big of a system, or even 10 kilowatt systems, we're really close to $1 per watt of a full cost for install, a full price for installed systems. But something I want to show that I think is more important, and especially for our countries, is what happens when we analyze the composition, the percentage composition of this cost structure. So if this is the same cost that I showed on the previous slide, but now just as a percentage of the total cost. And so we see, of course, we have an important component here by the solar panels, the inverter, then structures, electrical materials, and installation. Also gross margin, that, as I mentioned, this should not be confused with the utility or the earnings for the company, because it includes not only all of the administrative expense, as I said, the sales, marketing, and income tax as well, and the VAT. And with this, we see that even if we consider, even if in a scenario where all solar panels and inverters are 100% imported, the rest of the components are mostly local. In Argentina, on this review, on this research that we conducted, all of the electrical materials were local. We have cable factories here. All of the breakers and cabinets were made in Argentina. The structures as well, most of the solar installers have designed in some way their own mounting system, and they're improving on those systems, but this is locally manufactured. And of course, as we mentioned, the installation as well. So, okay, so So all of these are local materials and services that are included in the price, as well as taxes that we mentioned, VAT, income tax, and others. So if we look at this composition, we can see that about 2/3 of the total cost or the total investment that the user is making when purchasing these systems is local, which is very interesting, because there's also a perspective that most of the the main components are imported, so this might be an issue with the an issue with the trade balance in our countries, and this might not be the case. Also, I want to point out that while and this is a personal opinion, but I think most of you will agree, while the solar panel market is very concentrated in China or Asia, at least 90% comes from Asia, and it's already really well developed and has a massive scale efficiency. So it might be hard for us in Latin America to compete by manufacturing solar panels, especially the semiconductor wafers. The inverters, I'm not so sure we are that far from developing our own inverters, because we have a lot of power electronic manufacturers in different countries, and I think this is something that in some cases we should look into and try to expand this local component to benefit mostly our local economies. So now if we look at renewable energy jobs, and this is a report that's issued yearly, and we also recommend that check. This is data from up to 2018. This report was issued in June last year, but IRENA is publishing this report yearly, and it's interesting to see that solar PV industry, on average, in the last years, has created 375,000 new jobs, which is really, really important, and it's something that we should also try to grow and benefit from. You can see it in comparison to other renewable energy technologies. Of course, there is growth, but the most growth in job creation comes from solar PV, which is, of course, most of the distributed generation installations. Then if we look at the global perspective, we see, of course, this is distributed. This goes along with what we see when we look at installed capacity overall in renewable energy projects. But also it's interesting to see the very big size of the Brazilian market. So that's something that we're going to see a bit more in detail now. But there were 11 million jobs by the end of 2018 on renewable energy, and I think this is a very important thing to take in consideration. This was issued this year, and this is a statement by the association, the Brazilian Association of Solar PV, and what they mention is that the solar PV energy was responsible for creating over 37,000 jobs in Brazil on the first 5 months of 2020. And of course, this number might be an approximation, but this is a huge number, and it's something that we should look into and try to make the most of this technology to create much needed jobs, especially in this situation now when most of our countries are going to be facing recession, and there's a big challenge to create jobs as we come out of this COVID pandemic. Something also important to note, and that in this case and in most industries, but as we are in the renewable energy industry, we should always look for more diverse participation. In the case of women in renewable energy, we see from this research, but same research on energy and jobs by IRENA, that the renewable energy sector is better off than the average share in oil and gas, but this varies depending on the specific activity or sector. And I think that the improvement or the better perspective has to do a lot with the multi the multi disciplinary aspect of renewable energy. As you know, this is not only a technical or electrical issue or challenge. Is that there's a lot of administrative law and contract related issues, economical issues, development issues that are involved, and I think that's a good thing. And of course, when we look at some of the challenges that we discussed previously, and some of the future trends that we're going to see in a minute, it's really important. It's my personal opinion. I hope you share this. That it's really important to keep looking at these numbers, not only because it is to increase and to enable a more balanced participation in the sector, but also because these challenges, many of these challenges, we don't know the answer to our questions yet, and diversity in tackling these problems is key. So the most diverse work group that we can have, the better solutions that we might find for our shared challenges. So now when we start looking at challenges in DG, most of these we already discussed, but just to wrap up and point out some of the challenges that are present today. So technological challenges, as we saw from the technology point in solar PV, it's a very mature technology and it's already proven, but other technologies might need some development. We know, and we'll talk about a little bit about storage in a minute, but also other renewable energy generation technologies are at an earlier stage, and we probably can find improvements and better solutions to bring more diversity technology-wise to renewable energy. From the economic point of view, other than point out the maturity of solar PV and the cost reduction that we've experienced and expect to experience in the coming years, it's really important, and I think that's something that we touched on when we discussed the mechanisms for incentivizing distributed generation. But I think it's very important to adjust these incentives and always look at the long trend to avoid boom-bust cycles. So a boom-bust cycle means that sometimes because of excessive incentives, we might see a very steep increase in activity in the sector, but then once those incentives are removed, we see a very steep decline as well. And if we are having this growth, what we call boom and decline or bust cycles, this is something that even if in the long term we are increasing the size of the market, it's something that will in the bust cycles will lead to a lot of problems for the sector, for all the companies involved, and that could lead to job destruction during those cycles. And so this is something that that's really important, especially if you're on the regulatory side and you're looking at how to sustainably grow these markets. As for safety risks, again, I think the electricity sector has a lot of experience in general with generation technologies and solar PV. I really think that, I think it's key to look at what other countries are doing, and especially what the quality and safety certifications are. I don't think this is a problem for the technology, but from the regulatory side, it's important to take advantage of most of these advancements to make sure and stay safe on the safety of these systems for the end users, especially, and for the grid operators. As for grid impact, this is an ongoing question. So far, we don't have a massive penetration of distributed generation in most countries, and we're seeing, and most of the research as different grids are increasing their participation shows that the impact of variable and intermittent renewable energy is not as bad as originally thought, and in most cases, it can be mitigated, at least with current participation levels, but it's something that we'll still need to think going forward. And as I said, it's a very open sector. Most of the information is openly shared, and it's very important to look at what other markets and countries are doing, the ones that are ahead in these implementations, to make sure that we can operate our grids and systems safely going forward. So I think the most urgent challenges, or the short time challenges for Latin America, is to look at the regulation that we have, especially considering that the technology is here to stay, especially solar PV, but more technologies are going to come into this market and continue to impact how we manage and operate our grid. So there's no way to really impede the growth of these technologies or the participation of these technologies. I think maybe they'll be slowed down if the regulation is not present or not properly enforced, but future-looking regulation that enables these technologies without with taking into consideration the impact to some of the aspects that we mentioned, fixed cost distribution, grid stability, grid impact, is key going forward. Because if not, the systems will start to appear, and the grid operator will not know that they're there, and that will be harder to manage than having an open and proper window for these systems to be properly integrated. And then, of course, knowledge and training, and this is a new sector in many countries. Of course, we saw Brazil, Mexico, many countries, Guatemala, Costa Rica, that already have a lot of distributed generation and probably have many people who know and understand these technologies, but something that we should keep working on. And of course, I think Oyada is doing a great job on this front by trying to share, to create a common discussion on our different challenges. Again, not all solutions are applicable everywhere, but I think the challenges are similar, and we can all share ideas and take what worked and what didn't work everywhere, as well as training for installers and solution providers in the sector will make the grid impact a lot lower, and will provide a more safer integration of this technology. Now, when we look at future trends, of course, storage. We've all been hearing about storage in these recent years with solar PV or residential and commercial distributed generation. We normally see this demand and generation figure. So this is a typical residential demand on your left. This is a typical commercial demand curve on your right. So this is office hours in the commercial side, and more stable demand. In the case of residential, well, now that most of us are staying at home, this is different, than it's probably a more of a flat curve. But in any case, you see that because of the availability of the solar resource, most of the generation happens at times when, in the residential case, we don't have a lot of consumption, or in the commercial case, maybe we have excess generation that we cannot consume, and then during night hours we'll still have some demand from the grid. This is, of course, something that the storage comes to help with by storing this energy and then reducing the demand from the grid in the hours that we don't have our generation. And then another comment on this that we touched on when we discussed net metering and net billing. So while net metering doesn't have an incentive for storage from the user perspective, unless you provide an artificial incentive, one of the advantages of net billing is that, as you remember, the injections price is lower than the avoided cost of self-consumption. So the economic incentive is always to increase self-consumption, which in the future, as storage prices decrease, will provide at least some economical incentive by itself for users to store this energy when they have excess generation. Instead of injecting to the grid, they will see benefit in storing energy and then flattening this curve and reducing peak demand, which is also good for the grid because we'll have a more optimized capacity usage. If we look at trends in storage, we see that as it happened with solar PV, the reduction and the price reduction of batteries, especially lithium nowadays, but maybe some other technologies might arise in the near future, has been also dramatic. We're not yet at a point where the cost compared to the retail cost of electricity it doesn't justify itself in most cases without incentives, but we're getting there. And if we look at the future trends from this research by Bloomberg New Finance, you see that the expectation is to keep reducing this size. And also this is something that's driven not only by storage for residential or commercial use, also electric vehicles that we're gonna touch some points there. It's giving a pull on the development of these technologies. So this is a trend that's here to stay, and eventually it will start being incorporated in our grids. So with all this that we said, and going back to our first session, when we look at the long-term international trends, this is something that's really interesting. Based on the evolution not only of solar PV, but also of storage technologies going forward, there's an expectation that the decentralization trend will continue and will actually reach significant levels. If you look at this chart, and we see here some countries in Latin America, such as Brazil and Mexico, of course, which are the ones that have the most or growth in PV, and of course are the ones that have the biggest expectation going forward. But the decentralization ranges are expected to be between 10 and 50% by 2040, and even 10% it's a huge participation when you think of the generation sector or the grid as a whole. So this is something that's coming, and we should really be looking at the medium or long term and keeping an eye on these technologies as they develop. Something that's also interesting to point out is that we are going into a trend of electrification of the energy consumption. Of course, you can think of electric vehicles, but also in many of our countries, there's a big growth in climatization, air conditioning in particular, for example, or heating that's turning to the electrical side from other fuels. In many cases, this is because the grid coverage is different on the natural gas grid than the electricity grid. The electricity grids are normally more extended than natural gas networks. So we're seeing some tendencies that are telling us that we're going to be demanding more and more and more electricity from the grid. And if you look at electric vehicles, which in Latin America so far, the participation is not really important yet, but most of us can agree that this trend it's a matter of when, but not of what will happen. So eventually, when we start having a participation of electric vehicles, we'll start to see some shifts and changes on the general demand on the system. So we'll see two new phenomena. So the fixed charge on residential users, for example, at night when you get home and you start charging your electric vehicle, but also dynamic charging, which could be done at the parking lot of your work or at the supermarket or while traveling midday from one place to another. And if you look at this curve here is not only, of course, there's going to be an increase in the electrical demand and a decrease in the demand of fossil fuels, at least for vehicles, which is important also to think of how the energy is generated and make sure that there's renewables replacing those fossil fuels and not more fossil fuels. But instead of going into that, I wanted to point out that if you look at the curve and the impact here, you see that most of this change is going to happen during day hours, which coincides with the generation curve of solar PV. So this is something that's actually good, because as the demand increases on day hours, we can make the most of solar generation, which is right now dominating the distributed market. So some final comments on what we discussed. And as I said yesterday, the distributed generation is just the beginning. It's the most advanced technology today, but it's not the only change that's happening. So electricity systems are changing rapidly, becoming decentralized by disruptive technologies and user-driven changes. The user has changed, and the user is demanding different services and wants to do different things with energy. So these challenges are present, but also there's a lot of opportunities for grid operators and market participants to provide new services, whether it's demand response, well, of course, as we said, distributed generation, but also demand response, storage, and others that maybe we have not we have not thought of yet, but might happen when we start enabling this participation. So future-looking regulation and open and dynamic forecasting is essential. The demand changes now are going to be a lot more dynamic and harder to predict. So there's going to be a lot, modeling and forecasting will start to, will need to consider a lot more variables than it used to. Maybe grid planning, when you used to forecast the growth of the grid on long term, and you can consider, I don't know, 3% of demand growth every year, and then you can make an investment for a long-term capacity expansion on some circuit of the grid. Well, maybe that now that might change, and then once you did the investment, there's a sunk cost, and if the demand does not follow your expectation, that will increase the cost to all grid users. So I think storage will have a big role in this, and of course, distributed generation will help in mitigating this growth. This is an open question that I want to close with. Basically, the business model is, of course, the business model, especially for utilities, and in this case, distribution utilities, which are the most impacted by these new technologies, is requiring change. So the utility of the future might be more similar to a platform and an enabler of distributed energy resources, and we really need to keep asking ourselves that question, and how we imagine the utility of the future. What are the services, and what are the services that users are demanding right now? What are the services that they're going to demand in the future, and how can we be the most flexible, but also making sure that the business model works, because we all need the grid, and as we said, the electrification is also a trend. We'll need the electrical grid more than ever. So this is an open challenge, and I think a very interesting question for the entire electrical sector. That will be a key player in the energy transition. And with that, I will open to questions. Please, Adrian, if you can go ahead and read this.
Okay, many thanks, Ignacio. So let's read the questions. We have some from the first one from Alberto. Finally, what do you recommend, net metering or net billing?
Well, I guess yeah, of course, net billing in the case of Argentina, I think was the proper solution. I think going forward, net metering will tend to be more similar to net billing. There's something, so to me, it's easier to implement net billing and have the discussions and the explanations that you need to give the end user about why you're paying only for the generation price, but not the grid cost and tax that they pay when they pay the retail rate and so on. But once you have you're settled with that discussion, everything else gets easier. While with net metering, it might be easier at the beginning, but then down the road, there's going to be a lot more discussion. But if you think about, if you get outside of this net billing versus net metering discussion for a moment, and you think about the trend, what you see is that in most cases, the issue is that historically we have been using single energy, just energy meters for our tariffs, because it was easier, because the meters were cheaper, and the demand was very similar between these certain types of consumers. But now that this demand is changing, it makes a lot more sense to think of more complex tariff structures, such as the ones that we have in commercial or industrial users. So we might see a shift to having capacity charges on smaller and smaller users, which should not impact the total cost of your electric bill, because if you're still paying for the same cost of the grid and an X amount of energy, when you add up the cost of capacity or the cost of distribution grid and the cost of the electricity, you should come to the same number. So with this, what I mean is that if we start moving to tariff structures that represent better the real cost composition of each of these services on the grid, of course, there's going to be a complex discussion to teach and make the users, the end users, understand these changes and make sure that they can make the most of these new incentives to reduce capacity or reduce demand. But what I mean is, if you were in a situation where your capacity costs are, which is what represents the fixed cost of distribution of the distribution grid, are on one side, and the variable electricity or energy costs only include maybe the losses of distribution transmission, but not the fixed cost, net billing and net metering are not that different. So the issue really is not net metering. The issue is the tariff structure and the business model that we've been using in the electricity, the distribution grid for a long time, and that has been very useful and very simple to manage, but now it's getting more complex and harder to maintain. So in my personal opinion, I think it's easier to have the discussion on net billing first, rather than a couple of years after implementing net metering having to set a solar tax or a solar fee, increasing rates to other consumers, and that those discussions are not nice to any regulator. So that's my general opinion on this net metering versus net billing.
Many thanks, Ignacio. The next one from Leonardo. Storage the energy is only with batteries, or there is another method used? I mean, for commercial users above 20 kilowatt installations.
Well, nowadays that seems to be the technology that's closer to being economically viable. If you look at first of all, if you look at an historical perspective, or as the electricity system as a whole, we've had, in many cases, we have storage on hydropower plants. These are pump stations that can pump water from to the reservoir at night, for example, when electricity is abundant, and then make it run through the turbines again at night. But this is very resource and locational dependent. So if we go to the demand side, nowadays this seems to be the case. So batteries, and in particular lithium batteries, are dominating the market. I've seen some research on thermal storage or other means of storing energy. Maybe sometimes it's not electricity itself. For example, if you look at demand response and research, In many cases, they use thermal inertia to kind of store energy in a building instead of turning on the boiler or the heating, the HVAC system. You might heat up a little bit before when electricity or energy is cheap, and then keep it warm but turn off your boiler. So I think our electricity nowadays, that's the leading technology. But if you think of the energy consumption as a whole, you might find some other interesting ways of storing energy. This is also something that's interesting for when you think of solar, for example, solar systems for pumping, for water pumping in agricultural sectors. In many cases, they do have tanks or reservoirs that they can where they can accumulate water. So they could pump water on during the day and then accumulate this water. So they will not be storing electricity by itself, but they can have some sort of storage that will give them flexibility on the demand side.
Okay. The next one from Oscar. Please indicate some ideas to outline distributed generation policies in countries that do not yet have regulations or initiatives in this regard.
Okay. Well, we have covered a lot of ground on this, and mostly yesterday, I think we did a good overview of the different trade-offs between the different mechanisms. But I think if we look from a general perspective, so the regulatory frameworks should be thought of as flexible but also long-term. So you need to have regulation that provides certainty not only to the grid operators and the solar installers, but also users. So in this case, for example, in the case of Argentina, a national law instead of some local regulation is was a better idea, and that might apply also to the other countries. So I think you should think of open. I mean, first of all, you should take into consideration that this technology change is happening and that the users can go online and purchase solar panels, and maybe if they're daring enough, they can install them themselves. So this is going to happen whether you regulate it or not, and the chance that you have with regulation is to make this happen orderly and in a proper way, and also to provide incentives to develop this market and create jobs. So I think you should focus on key aspects of security, safety. Take a look at your tariff structure and try to work with the distribution utilities for them to understand that this needs implementation, and that the implementation should be done with the right impact. I mean, you cannot the distribution grids, and this is something I'm going to be on. This is something that I've seen in many cases, because of course there's inertia, and change is not always easy, but we should not mistake distribution natural monopolies that of course make a lot of sense on these regulated utilities, because we don't want to have multiple grids. That will be really expensive. But we should not mistake the natural monopoly of the grid operator, distribution grid operator, with the monopoly of selling electricity. Because if a user can generate electricity by himself, either by a diesel generator or solar panel now, there's no legal ground for the utility to avoid that happening. And actually, even morally, it'll be really hard, because in the case of renewables, we're all trying to decarbonize the grid. So I think the fairness of the regulation is important, in the sense that the distribution utility has to understand that if their business model is based on electricity sales, which is actually not what they're selling capacity and infrastructure, it will be impacted, and there's nothing you can do. So they will not be able to cover that for a long term, even if you forbid distributed generation, and that they work with them to think of what new technologies will be needed. So I think those are all the things that you need to take into consideration, and take a look at other countries' regulations in detail. There's countries that have full, complete regulation. We discussed the Argentina case, but of course you can go and take a look at Mexico or Brazil and talk to the regulators and see what, or Chile even. I spoke to the Chilean ministry a lot when starting to think about the net billing law, because of course the net billing mechanism was simple. We were trying to do something similar, and learned a lot about what they thought will happen and didn't happen, and what surprised them when implementing this. So I think sharing and leveraging on the knowledge of other markets is very important. And of course, following the trends of technology. But in that case, I think you need to stand on top of existing quality requirements and certifications, and you should not have a big problem. It's a very complex matter and question, but I hope I touched most of the points that are important for policies in this market.
Yes, it was a big question. To define it's very, the experience that you have can help us to conduct in a better way which one is the best option. So now about the question from Bernardino. From a technical point of view, what aspects of distributed generation need more research and development?
Well, I think at least the most interesting research I've been seeing lately is related to grids that have high degrees of penetration. So in the case of solar PV, for example, just saying penetration of generation, without getting into storage of other technologies that are not distributed generation, strictly speaking. So if you look at, for example, there's very interesting research from Hawaii done by NREL, the National Renewable Energy Lab from the United States. And why Hawaii? Because as you can imagine, it's an island, so it's an isolated system that has a very high penetration of distributed generation, and they are starting to see what the impact is to voltage, as we mentioned, capacity factors and power factors. I'm sorry, and harmonics, and what the real impact is to the grid when you really have a lot of these systems. Because before that we have a lot of academic research, but there's not a lot of on the ground examples that you can analyze with a lot of this generation. So if you look at this, you can also look. I don't remember the name of this standard. I will look at this and then I'll write it down when we write down the replies to these questions on the website. But there's an IEEE effort to also in the US, but in Europe as well. There's interest for this for implementing control. Let's see, volt bar controls, automatic volt bar controls in solar PV inverters, for example, so that or automatic derating of solar inverters, so that the solar inverters, when they sense that the power factor is going outside of the limit, or when they detect that the voltage of the grid is going outside of the allowed range, they can reduce their generation automatically and avoid that impact. And actually, if you look at that research from Hawaii, there's circuits where they have about 60% penetration, which is massive. And even with these functions, they have seen that this self-curtailment of solar inverters was only active for about 1 to 2% of the time. So, but this is something that's very interesting technology-wise. Looking forward, and then of course the impact of storage and how to manage storage, and what market signals we can provide to storage through tariff design to make sure that the impact to the grid is beneficial and to the other users as well.
Okay, the next one from Ruben. On slide 8, it is not clear to
Sorry,
me why
that's
the cost.
IEEE, Bernardino. Thank you very much. My memory is
Yeah,
not
yeah.
great, but in numbers. But thank you. That's the IEEE that I was referring to.
Okay. On slide 8, it is not clear to me why the cost of panels is higher for 50 kilowatt installations compared to smaller ones. In the inverter, the opposite trend is shown. Could you give us more detail?
Yes. Well, of course, you can look at the previous slide because one of the slides is cost and the other slide is percentage. So in the case of larger systems, for example, the solar panels, I consider the same cost for all three scenarios, which, if I recall well, is around 28 cents per watt. But if you look at inverters and if you look at the price of inverters, the reduction, when you increase size, the price per watt drops significantly. Then something similar happens in many cases for installation. This might depend on the type of installation because if you have a flat mounted system, then the structure that you need is a bit more. But if you look at the installation service and consider that on a per watt basis, it gets a lot cheaper because it's more efficient to mount a lot of panels. You basically have the same logistic cost to carry 4 solar panels and mount them on a roof, on a residential rooftop, than to carry 50 solar panels and mount them on a warehouse. So keep in mind that you're looking at percentages on one of the slides and at cost on the other slide. But in any case, if you have any other questions, then you can send me an email afterwards and I can reply to that.
Many thanks, Ignacio. And the last one from Enrique, the costs that you inform for the facilities take into account the useful life of the solar panels. Do you consider the amortization of the panels?
Well, this is an interesting question as well, and thanks for pointing this out. Well, in the cost of the system, which is the capex, right, the capital expenditure, you will not see that. I mean, you normally don't see that cost reduction by amortization of the capital investment. But if you were to do a cash flow, for example, to analyze the payback period or the internal rate of return or the net present value, for example, you should consider that in all commercial and industrial systems because they can deduct the cost of the investment, at least a percentage of the cost of the investment, from income taxes. So I think that's very important. And if you were to do a levelized cost of energy, and you wanted to levelized cost of energy is a great indicator if you want to compare with retail prices, because what you do is consider all the costs of the system and then divide all the electricity generated, all the cost of the system divided by the electricity generated during the lifetime of the system. You might want to include that as a deduction. In general, if you're talking about cost, you're not doing that. But then if you're trying to show what the real impact it is to a commercial industrial user, you might. But normally you don't do that when you talk about capex. Capex is clean from tax deductions.
Many thanks, Ignacio. I just want to thank you for the great webinar cycle. It was a very useful information. As a conclusion, I think that the region has the challenge to promote distributed generation, considering the CO2 emissions reduction that we can reach, considering the savings that we can reach from the electric power systems, and to promote a job. That was an interesting information that you showed. I think that considering the current situation, it could be a good way to promote jobs and to create new jobs in the region. No? So for me, it was a pleasure to have all of you, and I hope to see you again. Please, all the participants, if you can fill the survey that is in the platform. It will help us to promote and to improve this type of webinars. And again, Ignacio, many thanks for your cooperation, for your information. And I will share the questions so you can write and I can upload to the system and all the participants can.
Okay, thank you. And it's been a pleasure having this conversation with all the colleagues here through Olade. Thanks, Olade, for organizing, and Adrian. The organization has been great. You probably have experienced everything went very fluidly, and that's thanks to Adrian, who's been on top of everything. If you have any other comments or questions, you have my contact information, or you can contact me through Adrian or through Olade. And with time, I will reply to any question or comment that you have. Thank you very much.
Thank you again. And if you need more information or something, please go to Olade's website. That is a new website that we have now, so you can share information and everything that you need. We are open to support. Thanks again.